until about T-minus 4 minutes, a lot of stuff starts going down. T-minus 3 minutes, closing out the propellant load, so you're finishing out the liquid oxygen load and the liquid fuel load. T-minus 40 seconds, we stop interacting with the pad. The vehicle's just on its own.
All right, attention all B-19 operators. This is the final go, no-go poll for today's operations. Our main objective today is a 10-engine static fire.
Why 10 engines instead of all 33? This is the first V3 booster down at the pad right now, so there's a lot of stuff that can go wrong. And if we do have a bad day, it limits the scope of the issues that we can have.
This will be the highest chamber pressure we've ever seen on a vehicle at SpaceX, so definitely going to be a pretty spicy test today.
And then you're counting down from T-minus 40. T-minus 4 on is when my heart rate really starts to tick up. And then we light the engines.
We are in Star Factory, and this is an almost 1 million square foot facility that we've built to enable that production of both ship and booster. Starship is a fully reusable rocket. It's 2 stages, so it has a ship, which is the upper stage, and a booster below it. The booster accelerates the ship to get it going towards orbit. The ship is what actually goes into orbit to take the people or the payload to wherever they're going. The sound of progress. The rivet guns and the sledgehammers. Less sledgehammers than there used to be. The story of Starship starts with the founding of SpaceX.
3, 2, 1.
Rather than starting with the vehicle that Elon envisioned needing to get people to the moon and Mars, he thought it would basically bankrupt the company. It wouldn't be possible. So you have to bite it off in small pieces. And so those pieces, which at the time did not seem small at all, were Falcon 1, Falcon 9, Dragon, both cargo and crew, Falcon Heavy.
Falcon Heavy is supersonic.
These were the building blocks that let us cut our teeth on learning how to do rockets. Not the way the aerospace industry had been doing it, but the way we needed to do it to end up here where we are today working on Starship. Version 3 is what I like to call the foundational design of Starship booster in the pad. That's going to give us the new capabilities we need to do the missions in front of us. It'll be the one that puts humans back on the moon. It'll be the ones that put the first boot prints and then city on Mars. Starship is giant, and that scale is not an accident. It's not to win some Guinness World Record prize, which we did for both the ship and the tower. It's because we need that size to do the things we dream of doing with it.
Ship 39 is the first V3 rocket. This rocket is unlike anything anybody's ever done before. Version 3 is basically a clean sheet design of the ship. We essentially took a bunch of lessons from version 1 and version 2, and we took a step back and said, what were the things that were really problematic, either from a performance perspective or from a reliability perspective on the previous rockets? And then we directly addressed those with a variety of new designs. It can go up to orbit, it can stay on orbit for 48 hours, it can meet up with other ships, and it can do propellant transfers, which is really the core technology that you need to unlock Starship. Once you unlock that capability, the whole solar system is on your doorstep. And right now what we're doing is we're actually going through checkouts. So we're actually kind of bringing the rocket to life.
We've never built a ship V3 before and gotten it to this state of production. So we are going to have special things to this specific vehicle that are going to be odd, but there's also things about the architecture as a whole that we don't really know how to deal with because we've only done simulations, we've only built fluid models of how we think a ship V3 operates. Now we have the real deal next to us.
First priority is your safety, the second priority is make sure the vehicle's okay, and then we worry about executing to our schedule.
We're quite excited, we're quite anxious, but all things considered, we're pretty well prepared. We think that we'll have a good result.
We intentionally started Starship with the ship portion because it was so novel. We have done a reusable booster before with Falcon 9, and so it's at least a little bit better tread ground. I will say, I think the booster turned out to be a lot harder than we gave it credit for.
This is an entirely new rocket. This is the most ambitious vehicle design I have ever personally worked on, and it is a wild thing to see come to reality here. The version 1 flight test campaign really exemplifies the rapid integrated test style that we do in SpaceX engineering. It took us 5 flights from our first attempt, from flight 1 to flight 5, to successfully catch a booster, which was honestly mind-blowing. Flight 1 was able to get off the pad successfully. It proved that we could get this full system together, and we learned a lot from the eventual failure of the vehicle in that flight. We were able to put together a lot of improvements on the launch pad and on the vehicle hardware design that led to much better success in Flight 2. We were able to make it with the booster to MECO. We were able to separate the ship, and we were able to begin boosting back towards the launch site. So we hit the next big milestone in the flight test campaign. On Flight 3, we were able to get all the way through our boost back burn. On Flight 4, we were able to do a successful water landing demonstration. And on Flight 5, we were able to come back to our launch site and successfully catch the vehicle with our chopsticks. To be able to go fly that and have complete mission success at that point of we got the payload to orbit and we landed that rocket was incredible. I'm getting goosebumps talking about it now. We're about to get into a really exciting period of the vehicle test campaign here, putting the thing through its paces and making sure that everything we design works okay.
Want to stop about right here?
To get all of the pieces of the system working together for the first time, and if we're going to learn anything from that, we'll learn it as quickly as we possibly can. Booster 19 is actually the second of the version 3 boosters that we've built. Booster 18 came before it. We had an unfortunate anomaly during our first test campaign of the Booster 18 vehicle. This is the first version 3 booster that we built, so this is Booster 18. This is really awesome because it's going to be our first full vehicle level operation and test with a version 3 vehicle. So the whole team's very excited about this. Sure hope it works. When we were pressing the nitrogen system, we had an explosion that took out the rocket, and thankfully we had designed that test to be safe. If something like that happened, we did not have propellants or reactive things on the vehicle, and so the test site incurred very little damage, and of course nobody was hurt in the incident.
Yeah, as part of testing, this is loud, so you learn to not be super skittish as you're walking around. So we have our booster here on site. We're going to be performing a cryo-proof. It's actually a really long day, so it's nominally planned to be a 12-hour overall prop load and offload. It's just a ton of propellant that we're putting on the vehicle, and we do a bunch of test cases throughout the whole day. So it's a long one.
Taking booster SM to cryo high fill proof.
Cryo-proof is the first time you actually put propellant onto the vehicle. The liquid propellant that we're putting on, it does get pretty cold, generally in the 80 Kelvin range. We want to test like you fly and fly like you test.
No on 70% proof percentage. Stay firm. And fuel interface is fully cryo now.
There is definitely nothing like a late night with your team in the control room. It's one of those milestones where you're like, wow, if I can load a rocket, this is amazing.
The FHT looks pretty stable. Let's go ahead and get booster configured for offload. Copy.
This is a Raptor 3. V3 is a high-performance boost engine. It's also designed to be reusable and highly reliable. We've learned a lot over the course of producing around 600 V2 engines. You can see the amount of simplification that's occurred between V2 and V3. The level of integration is really unique for rocket engine. That comes from a lot of work among many engineers to consolidate the hardware. The effect of that is that it's actually a higher reliability design. So fewer parts is cheaper, faster to build. So that allows us to make a lighter vehicle, to make a more reliable vehicle, to overall just build a better rocket. Achieving full reusability of an engine like this is really something that people haven't done before. The goal is to get the engine to behave in a similar way to the engines on commercial airplanes. Frequently in interactions with people outside of SpaceX, the perception is that things far beyond what have ever been done before are impossible. Things being impossible is really to be determined by breaking laws of physics. We are not breaking laws of physics, we're just trying to leverage them as effectively as we can.
All right, attention all B-19 operators. This is the final go, no go poll for today's operations. Our main objective today is a 10-engine static fighter.
Static fire is the culmination of the engineering process. We are bringing all of the pieces of the puzzle together, and we are lighting the engines. And if you make it through that, you have pretty good confidence that you're in a good position to go fly.
Abort. On LVN1, looks like we kicked out due to 2 combustors from the apex bank being pelted.
Looks like we have to engine time of 2.135 seconds.
We successfully lit all 10 engines. They were ramping up to power. Everything was looking good, stage and engines combined. However, there was a pad side abort called. So what that means is some sort of sensor tripped, and from there we command a fast shutdown.
It was a hard one, and especially since we had to drop all the engines afterwards, and thankfully 10 of them were salvageable, which is good.
We saw some data right after static fire that showed about half the engines had what looked like mechanical damage, basically as a result of the really fast shutdown. So we brought the booster back to Mega Bay. We then decided to remove all 10 engines from the booster so that we could troubleshoot and understand what's going on those 10 while still making progress on B-19 by backfilling engines from B-20.
All right, attention all operators on LVN1. Today's main objective is a 33-engine static fire on B-19. Okay, go no go poll coming up in 1 minute.
So we're doing our static fire today with all 33 engines.
This is the final go no go poll for today's operations. Flight software.
Go.
AY.
Go.
Raptor.
Go.
Stage.
Go.
CE.
Go.
GC2.
Go.
GC1.
Go.
FC1.
Go.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, mission.
Wow.
We kicked out early. All teams triage alerts, prepare for offload.
Today we aborted our second attempt of the B-19 full count static fire. We actually had another pad abort on the diverter. We made it through engine startup and then ultimately lost some of our sensors on one of the ramp manifolds. It basically said that the manifold pressure was lower than we believed that it probably was, and it kicked us out at T plus 1.88 seconds. It's just tough because there are some things that are hard to test ahead of time. So the diverter, you can test as much as you want, but you can't obviously test for what theoretical vibe and environment you're going to see when the engines are turned on.
Anytime that you walk into an operation where you want to turn on 33 of these enormously powerful engines and get them all to work together and walk away from it in one piece, that is a win.
I think every test is always a success, and we had a bunch of findings on the ground systems, the vehicle, and the engines that I think were really good to flag at this point, but definitely a bittersweet day.
We have this saying called only the paranoid survive. The idea behind it is that there's an enormous amount of information and data that's coming to you, and if you can use that wisely, you can usually use that to figure out where things are going to go wrong in the future. And almost every time that we fail something or have something go awry, there were clues in previous data and previous operations that if you had known what to look for and had been good enough and paranoid enough to do so, could have found it there.
It's been 10 months since Massey's had the S-36 anomaly.
Ship 36 was a tough one. We had a CPV explode, and it not only took out the rocket, but it took out a lot of the test site infrastructure over at Massey's.
How do we go make sure if we have an anomaly again, the pad can take a beating and still survive?
Losing a rocket is one thing. We've got a production line for rockets, and we can go make more. Losing the physical infrastructure of the launch pad or the test site is very difficult because you need to go repair that over a period of many months before you can get back into testing. Now we have Massey's back online here. We've really, built this rocket from scratch, but we've also built the pad from scratch, so it's all kinds of new systems. This will be the first time that we bring together the pad and vehicle pieces to make sure that they all work.
Static fire vehicle is in pre-pad clear, about to get to our static fire pad cleared op state.
We run 60 seconds on ship because you get to see how the vehicle thermals all shake out and just general vehicle performance.
That if you can make it through that you are in a reasonable position to go fly.
Start up. Throttle up. Plus 10.
The journey of SpaceX is a journey to give humans access to the solar system and beyond, which is really the goal for Starship.
Plus 20.
The impact that this rocket is going to have on the world, I don't think most people can really comprehend the change it's going to have.
Plus 30.
This is such a wild ride. The highs are high, the lows are low as we really work to get to ultimately launching people, which is going to be amazing.
Plus 40.
It is not impossible just because it's far beyond what has been done before. We've proved that time and time again.
Plus 50. Full duration.